All right, here we have another property. So things are going to change a little bit with this property. This is secant. Remember, a secant is a line that passes through a circle and touches it in two places, or similar to a chord. Okay, so BC and AD are both chords. Okay, if two secants or two chords intersect in the interior of the circle, the measure of each angle formed is half the sum of the measures of its intercepted arcs. Okay, so that's a lot to swallow. What they're saying is if you have two lines and they intersect inside the circle but not in the center, they can't be right in the center, just any other place inside the circle. Notice we have four angles created here. We've labeled this angle here. If we're looking for this angle, it is half of the two arcs created. Okay, so the arcs inside of it. So here's one arc, and notice across from it on the other side is another. These are our two arcs. Okay, so the angle is equal to 1/2 still, but it's not of just one arc, it's of the two arcs added together. So we're not having a vertex on the circle. Our vertex for our angle is inside the circle, not in the center. And again, what you do is you go, okay, where's my angle? Look and see what arc it creates. Notice the lines continue in the opposite direction, also creating another arc on the other side. What you're going to do is add the two arcs and divide by 2. So for example, if this arc were 28 and this one were 140, my angle would be equal to 1/2 of 28 plus 140. So half of 168, or 84. Okay, and again, this comes from the fact that two arcs are created if your vertex is not on the circle. So we have to take them both into account. So let's take a look at this example. Find the measure of angle SQR. Where is SQR? Here's the angle is at Q. We start at S, down to Q, out to R. So this is my angle I'm trying to find right here. Now notice its vertex is inside the circle. It's not on the edge. It's not right in the middle. It's just on the interior. Notice also that my lines create two arcs, the lines here. Okay, so in here, we have a 100-degree, and on the opposite side, we have a 32-degree arc. Since the vertex is on the inside, not on the edge of the circle, we use our formula that the angle is half of the two arcs added together. I'm going to call them arc 1 and arc 2. Okay, so in this case I put in my information. One of the arcs is 100 degrees, the other is 32 degrees. I go ahead and add those together, and I get 1/2 of 132, or 66. Okay, so the measure of that angle would be 66 degrees. All right, here's a couple more examples. Find the measure of angle ABD. So where is ABD? It starts at A. Here's B. My vertex is in the middle of the name and out to D. So here's my angle I'm looking for right here. Again, notice its vertex is inside the circle, not on the edge. So I know I'm going to be using the formula that the angle is equal to half of the two arcs it creates added together, arc 1 and arc 2. Okay, so whereas one of the arcs here, notice that's created is 65 degrees. We continue the other direction. We have a 37-degree arc. So our angle is 1/2 of 65 plus 37. Okay, that gives me 1/2 of 102. And 102 divided by 2 is 51. So the measure of angle ABD is 51 degrees. Oddly enough, if they asked for angle EBC, it's also going to be 51 degrees. Next, find the measure of angle MNQ. Okay, so let's figure out where that angle is. Here's M, down to N, out to Q. So here's our angle right here, this opening. So let's look at what arcs it creates. Well, it creates an arc here on this side, and then across from it on the other side, it creates this large arc here. Okay, notice again, the vertex is inside the circle, not on the edge, so we know we have to work with two arcs, and we use the formula that the angle is equal to half of the arcs added together. Okay, so we get 1/2 of 91 plus 225. Go ahead and add those together. Gives me half of 316. 316 divided by 2 is 158. All right, here's another. What's the measure of angle HFG? So where is that angle? Here's from H to F to G. Again, the middle letter is where your vertex is located. Okay, notice again, my vertex for my angle is inside the circle, not on the edge of the circle. So I know I'm going to be using the formula that the angle equals 1/2 of the two arcs added together. Okay, so I take a look at that. What are my two arcs that are created? Well, there's a 35-degree angle arc here, and if we extend our sides over, we create a 61-degree arc on the other side. So we go ahead and put those in. It's going to be 1/2 of 35 plus 61. Go ahead and add 35 and 61 first, which gives us 96, and divide by 2. Half of 96 gives us 48. So our angle HFG would be 48 degrees.